Hello and welcome to m200 Online Statistics at Cañada College. My name is Lapuz. In this video we'll do a homework problem from section 10.2. It says that the data below shows the selling price and the list price of homes sold, and they want us to construct a scatter plot and find the value of the linear correlation coefficient and the p-value using a 0.05 significance level. And that is to answer, is there sufficient evidence to conclude that there is linear correlation between the two variables? So for all these problems, having a linear correlation means that your rho value, the correlation coefficient for the population, is far away from 0 as possible. Now the rho values only go between -1 and 1, and so far away from 0 means like 0.9 or -0.87, and to say that rho is equal to 0 means that there is no correlation. And so this is going to be our choice for the null and alternative hypothesis. Next, they want us to find a scatter plot, and so what we'll do is copy this into our clipboard and paste it onto our Google Sheets. And while we have these two columns highlighted, we can go to Insert, Chart, and in Google Sheets they give us a variety of choices for our charts. We can do a column chart, and the list is really pretty long for the types of charts that you can have, but clearly we're looking for a scatter plot. They call it scatter chart, and it looks like our numbers pretty much go close, very close to a straight line, going positive, in a positive direction, going upward. And so let's take a look at the choices. We have D, which is going downward, and B, which is really scattered all over the place, and then A and C look like they would be good candidates. And if we take a look at our chart again, it looks like it's pretty tight, it's pretty close to a straight line, so I think I will choose C for this one. You can also make some adjustments in your scatter plot. Once we have the type of plot that we want, we can customize it, and we can fix the horizontal axis and the vertical axis. It looks like the vertical axis for the choices that we have start at 300, and so we can do the same thing here for the vertical axis, and we can have the minimum value for the vertical axis to be 300 and make it go up to 500. And then now it looks a lot closer like the problem, or like choice C in the problem. Next, they want us to find the correlation coefficient. So let's go back to our graph over here. Let's put this graph away for now, or shrink it, and focus on some of the numerical calculations that we need. My spreadsheet is kind of set up already. I just have the commands listed here, and I'll retype them to get the actual values. So to figure out n, you can simply look at how many numbers you have in your list, or you can use the command count. So let's type count, C-O-U-N-T, open parentheses, and let's just click on any of these or either of these columns, and then it'll count the numerical values and ignore the non-numerical values. So in this case my count is 10. That's going to be my n. The degrees of freedom for this is going to be n-2, not the n-1 that we've been seeing in the past. So let's make sure we click on n-2. Now our special command for the correlation coefficient is correl, C-O-R-R-E-L. So let's go ahead and type that. Equals correl open parentheses. Now it's looking for two lists or two sets of data, the Y list and the X list. So I'll click on B, comma, and I'll click on A to give me all those values. And notice again, it ignores the headers because it knows that you have some headers there. So we have 0.992, which is a really strong correlation, and we kind of saw that by the graph already. So let's put 0.992 for our correlation. Next, they want us to find a test statistic, and let's go down. The next things in my list are some regression values, which we'll ignore right now. This doesn't pop up till chapter or section 10.3. For the test statistic, it's going to be r divided by some square root, and so the square root is it's called the standard error of the correlation, but let's just call it SR for now, and notice that this is just a square root command. So this is just the denominator of your test statistic. Let's type sqrt open parentheses. We need the r value, or I'm sorry, we just do the square root. So that's 1 minus r squared. Because you're adding and subtracting in a fraction, let's add another set of parentheses, and we'll type 1 minus, and then we'll click on r, and then we'll square that. R squared, close the parentheses. So that's the numerator of the square root, and then we'll divide by n minus 2. That's just the degrees of freedom, but if you want to follow the formula, let's add another parentheses, click on n minus 2. Close the parentheses for the denominator, close the parentheses for the sqrt function, and we're all set. That's not what we want. We want t, so that's just r divided by this quantity that we just found. So let's say equals, let's click on the r value divided by and the sr value, and we get a really large test statistic here for our t distribution. So 22.78 or 22.79, 22.788, well, it's rounded to 3 decimal places, so 7889. Okay. Next, they want us to find our p-value. Remember that this is the area in the tail of 22.78, and it's in 2 tails. So we'll use this formula, this command called t.dist.2t, and the 2t, remember, stands for 2 tail. So we'll say we'll say equals, and then t.dist.2t, and then we want our test statistic, which is this number that we just found, comma, our degrees of freedom, which is n minus 2, or we already have that computed as 8. Because 22 is such a large number, this is going to be a really small number, so we get 0.000, bunch of zeros. If you're to punch this in your calculator, you're going to get 1.457 times e to the whatever the appropriate number is, and it looks like it's going to be 1, 2, 3, 4, 5, 6, 7, 8, I think to the -8 or -9 power or something like that. But for our purposes, we can just type 0 in because it's really small. Because the p-value is really small, which is way less than the significance level 0.05, we can conclude that we can reject the null hypothesis. We can reject rho equals 0, which is to say no correlation, and say that there is sufficient evidence to support the claim that there is correlation. Alright, I hope that helps.